In today's class, you're going to receive a handout just like the one that you can see here that is called Exponential Modeling of the Farm Value of Potatoes. And in a nutshell, I'm going to have you go to Statistic Canada's database called ESTAT and have you find data on the value of potatoes. That is the farm value of potatoes over a range of years from 1950 to 2009. The reason why I need you to find that data is for you to plot the value or the dollar value against time in years, and then to determine the equation that would model that data. And you're going to see that it is an exponential function of the form that we discussed in class. So let's begin by getting to ESTAT. You can type this into your browser. I'm just going to press Control and click on that to open that link. So here we are at ESTAT, and what I'm going to do is try to set up a double screen, if at all possible. We'll see if that's going to work well for us. Okay, let's try this. So at ESTAT, we'll go into English. And on the left-hand side, you can see that it does say click on Accept and Enter. Now scrolling through, it appears as that is not there, so we'll go to the next step. It says to search CANSIM. So CANSIM here in the left-hand toolbar is here. CANSIM is simply the database that contains time series data, which simply means data that's been collected over a series of years. Now that we're here, in the search bar, we're going to input this table number, and we'll perform the search. And as you can see here, that it gives us the table number, the information that's provided in the table. So it is the production and farm value of potatoes on an annual basis. Underneath, you'll see that it says note, you must select at least one item from each of the lists below. So we can actually fine-tune what portions of the data we want to use as based on country, province, area, and all sorts of different variables. We can even specify the time period. So according to the handout, what we're going to do is select all of Canada. We will then look to select total farm value of potatoes in dollars. In time period, we're going to go back to 1950. And in terms of the end year, we'll pick the most current year. Let's try 2010, even though the handout does say 2009. And over here, it says to retrieve as individual time series. So let's do that. Okay. So now that we've completed step number 7 here, we just finished this one. In the next instruction, it's going to ask us how we would like the data to be outputted. So under screen output, we're going to select table. You can see it here, table. And we're going to go with plain text and time as rows. With that being selected, we'll click on Retrieve Now. So what you can see here is the year as the independent variable, or X, and the farm value in potatoes in terms of dollars. Our task now is to import that data into Fathom. So once you've outputted data in ESTAT from Statistics Canada, all we need to do is to highlight the data. I'm going to copy this data, and then you're going to open a Fathom document. I have one ready to go right now. I already dragged down a collection box from the toolbar, and what we'll do is we're going to right click on that and we're going to paste cases. Notice that the box is now filled. If I then pull down a data table, we're going to notice that the years have gone into column 1 and the farm value into column 2. So at this moment in time, let's rename our collection as farm value of potatoes. And then let's go ahead and name our attributes. So this would be year. And this one here would be our value. And that's in dollars. Perfect. Let's go back to the handout to see what we need to do now. So we have imported the data. I have not saved the file yet, but as you're working on your own, I would suggest you do the same. Now, step number 3 might seem a bit peculiar, year since 1950, but let me explain a reason behind that. If we were to graph this, year would go along the x-axis and value would go here. Typically, when we're creating graphs, we tend to use 0 as an initial value, even along this axis here. And in terms of using an equation, it might actually be to our benefit to use smaller numbers than it would be to use these values for x. So let me delete this graph. And what we're going to do is create a new attribute. So up here, let's name this one years since 1950. And what we'll do is we're going to right click on the column. We'll edit a formula and let's enter this in. So we're going to take the year, and from that we'll subtract 1950. So let's apply this, press OK, and you can see that Fathom has formatted that column correctly. 1950 would be year 0, 1951 would be the first year since 1950, 1952 the second year since 1950, and so on and so forth. Okay, so according to step 4, we now create a scatter plot. With dollar value on the y-axis and years since on the x-axis. So we have the same graph, it's just that the scale has been changed. Okay. Now, it does ask you to go to your worksheet and answer numbers 1 through 5. You'll see those here, questions 1 through 5. Now, the thing with questions 1 through 5, the only thing there is that you would have had to have completed number 5. So let's go ahead and set that up. We'll do a reminder or a refresher on how to use sliders in Fathom, and then you can go back to the worksheet and continue your work there. So in Fathom, if we're going to do a quadratic fit or an exponential fit, we're going to need sliders. And for an exponential fit, the equation is y equals ab to the power of x. So we're going to need two sliders, one for a and one for b. So let's bring those two sliders in. The first will be renamed as a. The second one will be renamed b. And on the graph, we're going to right click and plot a function. And as opposed to using the letters a, b, and y, and x, we're going to use, we will use a. We'll multiply that by b to the power of, instead of x, notice that our x is years since 1950. So under attributes, select years since 1950. We'll apply that formula and press OK. Notice we have a curve that does not fit the data, so therefore we need to adjust this. Now according to the a value, we learned that that was the initial value or y-intercept in class, so it would stand to reason that it should likely be somewhere in the range of 54,000, as this was the first data value, provided that it does fit the nearby data. So let's change this a value to, let's say 55,000. We'll go 54. And for the b value, remember that when the b value, or the growth factor, is greater than 1, we experience growth. Now at a value of 5, it's apparently far too high. So we need to reduce that value. And we'll see the curve bend down. And at a value of 1, it goes to a straight line. So we need to increase that ever so slightly. So even at 1.33, it's far too small. So let's do a manual fit. Let's try 1.05. That's fairly close. Notice that it does fit the curve well for these values, but it does seem to eliminate the ones at the top. Let's try 1.06. Too much. Let's try 1.055. A much better fit at 1.055. So notice that I can't see that last decimal place, so we'll double click and we'll just adjust the b value. We'll take it from a range of 1 to 1 point, let's say 0, 6, and here we can then set our b value accordingly. Given that value, I'd say that's a fairly strong fit. So when you go back to your lesson file, one of the questions will likely ask you about the equation. So the farm value y in dollars would be equal to an initial dollar value of 54,000 multiplied by a growth factor of 1.0537. That's about